Okay, dear students, now let us start with the next the module, that is the module 4. It's about the normalization. That means the data in this case will be concentrating on all these topics, database design theory. So here we first will see what is introduction to the normalization using a functional and multi-value dependency, and we'll also see the informal design guidelines for relational schema, functional dependency, and the normal forms. This is very important, the topic in this case, informal design guidance of relational schema, functional dependency, and normal forms. That is first normal form, second normal form, third normal form, voice code normal form, multi-value dependency, and fourth normal form, and joint dependency, and fifth normal form. All these topics are very important. Then we'll also concentrate on normalization algorithm, that is inference rules. Whatever we have studied in the frame, the same thing it has been covered. That is, we'll also see some of the some algorithm is there, how you can find out the minimal cover for the functional dependency, and the properties of relational decomposition, and algorithms for this relational database design schema, and null and dangling tuples, and also the alternative relational designs, further dependencies of four normal form and all. In order to study these particular the topic, so these are all the textbook, that what textbook, and in each topics that you need to concentrate, it has been defined in this case. Now let us start with exactly the normalization. So that we usually call that as in the database design. The database design means, assume that now you are going to design one database here. So whenever if you want to design any database application, so we say that the tables must be in the normal forms here. What exactly, why we are saying that the tables must be in the normal form? The normal form means that, when do we say that the table is in normal form is, so there should not be any redundancy, that is the one thing. And another thing is that, so whatever the record that you are going to insert into the table, it should be an accurate. There should not be an inconsistency, the third one, and the second one. And the third one is, so if you assume that if you are combining the two tables together here, then after splitting the two tables, there should not be any loss of information. That we usually call that as a joinless property. So if it obey all these three rules, that is no redundancy, then no inconsistent value, and another one is joinless property, all together will be said that the table is in what exactly? The normal form here. To make that the table to be in the normal form here, or whenever if you want to design some any relational schema or any database here, so the first concept is that we should follow some of the guidelines. To what exactly? We should follow some of the guidelines to design the relational schema. That is very important, the topic. That is informal design guidelines for relational schema. Assume that now you are going to design one database here. Whenever if you are going to design any database here, so what guidelines we should follow here? That guidelines we usually call that as an informal design guidelines for relational schema, one thing. Then after that, functional dependency and normal form based on the primary case here. Whenever if you are creating any relations here, there should be a dependency. That means the non-key attribute must be dependent on what exactly? The key attribute. And we'll also have some of the normal forms here. That is, the normal forms is called as an first normal form, second normal form, third normal form, BCNF, and fourth normal form, and final normal form here. So when do we say that the table is in normal form is if it satisfies all these normal form. So that means when you go for higher normal form, it should satisfy the lower normal form. That means if we say that the table is in 2NF, that means it should be in what exactly? It should be in first 1NF. Then we can say that the 2NF. Like that, when we keep on going for the higher normal form, it should always obey the rules of what exactly? The basic normal form here. Then after that, we'll concentrating on the general definitions of the second normal form, and first normal form, and boys code normal form. All these topics will be concentrating. Now, we'll see the normalization. The normalization means, so here the goodness of the schema, when do we say that the table is good here? That is, goodness of the schema can consist or constrained at two levels here. That is, one is logical or the conceptual level, and another one is the storage or implementation level. That means what it says that here, so how the tuples in the base relation is stored and updated here. That is what, based on this, the goodness of the schema can be done at two levels, conceptual level and in the conceptual level means how you are going to define the concept of the database. Implementation level means how the data is going to be stored or how the tuples in the base relation is stored and updated here. All this is called actually the normalization. So this database design, whenever if you are designing the database, it performed by the two methods here. That is, one is the bottom-up approach and another one is the top-up approach here. So that means you can design by synthesis or else you can design by analysis here. That is what we call that as the two level. Normalization, what is the need for the normalization? As I told that, to remove the redundancy and make the data or the record consistent or the accurate here. Then now let us see, now assume that now I am going to design the database here, relational schema. This is very important, the topic, informal design guidelines for relational schema. This is for 8 marks or for 6 marks, compulsory. Compulsory asking question this one. Suppose I want to design some relational schema. I want to design the database here. What guidelines I should follow to design the good relational schema here? There are mainly 4 informal design guidelines. That is, first one is semantic of the attribute, and second one is reducing redundant values in a tuple, and the third one is reducing null values in a tuples, and the fourth one is disallowing the possibility of generation of the spurious tuples. The generation of spurious tuples means it's not a valid value, it's not a valid data. That is, we call that as the spurious tuples here. So if I want to design any good relational schema, I should follow these guidelines here. One is semantic of the attribute, reducing redundant values in the tuples, and reducing null values in the tuples, and disallowing the possibility of generation of the spurious tuples here. Now let us see the first one here. So semantics of the attribute. Semantic in the means the meaning of the attribute. The word semantic refers to what exactly? Refers to the meaning of the attribute. Here the attribute means we can say that how the attribute values in a tuple relate to one another here. For example, if I take the employee relation, you can see that each record of an employee which gives an information of a single employee here. That means you can see that how the attribute values are related with one another. If I have the employee ID, employee name, salary and the age, each tuple which gives the information of one particular the employee. That is, what is his ID, what is his name, or what is the age, and what is the salary of all these things here. So how to what guideline we should follow to provide the semantic of the attribute means. So for that we say that guideline 1 is, so the design the relational schema in such a way that do not compare the multiple attributes from the different entity types to form a single relation here. That means how we can provide the semantic of the attribute means, so to provide the semantics of the attribute, I should follow one guideline here. What is that guideline? Whenever if I want to design the any database here, whenever if I want to design the any relational schema, if I want to combine some attribute, multiple attribute from the different relation here, I should take care of that. So that means if I take the student and if I take the employee, if I try to join these two relations, whether it will give the exact data here, each record will not give the exact, because suppose assume that in the student the database have taken student ID and the student name here, or the student ID and the class. If I take the employee in the employee, if I take the salary and the address here, So when I join this, whether each record will give the proper information? No, it won't give, because it gives some two tuples, two attributes which gives the information of the student and two attributes which gives the employee information. So to provide the semantics of the attribute, what as a designer, what I should follow, what guideline I should follow is design a relational schema in such a way that do not combine multiple attributes from the different entity types to form what exactly? To form a single relation here. That is the one thing. Okay. And another one is, second one is reducing redundant values in it. So what will happen if I have the redundant values here? If I have what exactly? The more redundant values. What will happen if I have the more redundant values here? So here, if I have the more redundant values in my table here, there may be the three possible problems here. What is that? The first one is insertion anomaly. Anomaly in the sense the problem. First one is insertion anomaly. Second one is the deletion anomaly. And the third one is update anomaly. Update, or we can also say that is what exactly? Update, or we can also say that there is the modify anomalies here. That means if I have the redundant values in a tuples, there are three possible problems can occur. That is, first one is insertion anomaly, second one is deletion anomaly, and the third one is update or modify anomaly. An example here. I have one table called actually the loan here, which gives an information about the branch ID, the branch name, branch city, assets, loan number, customer name, and the amount here. So here in this case, consider a simple schema depicting the bank transaction to store the loan details here. Here, some XYZ bank has several branches which is located at the different places, and the customers can avail the loan from more than one branch here. So each customer will be assigned to the loan number, and it is different for each branch here. Our main aim is to store this information in a relation which we call that the relation name as a loan, which gives an information about all these things here. Let us explain these three different, that is what? Insertion anomaly, and deletion anomaly, and update anomaly with respect to this relation called loan here. Now, let us take it to the first one called actually the insertion anomaly. What is that insertion anomaly? You can see that I already have the branch ID, branch name, branch city, assets, loan number, customer name, and amount. Suppose if I want to add the new branch here, the new branch with the branch name is, let us take the branch name is Koramangala branch, which is Koramangala branch is open, and assume that I am going to insert the new branch here. The branch name is Koramangala, and assume that there are no particular customers, there are no one has offered a loan. So there are no one has offered a loan here. In this situation, what will happen here? You can see that 950 is the branch ID, Koramangala, Bangalore, and asset is 10,000. Assume that no one has taken the loan from this particular branch. So here in this case, here when I do this, you can see the first four attribute values will actually, it has an already here. Why? Because here it has some